Hello folks, this is Shadul Gawande from Ace Knowledge, and after successfully completing IP static routing, now we are going to start with practicals based on RIP, which is Routing Information Protocol. So what is RIP? So RIP is basically helps to route your data packets from source to destination with the best possible hop count. So now what is this hop count and what does this statement define? So here I have created an image for the explanation. Okay, so you can see over here, this is our user. For example, this is me. Okay, this is my computer, and I want to ping to, or you can simply say I want to communicate with or send data to google.com or get in touch with google.com. So these are the routers which you can see. Okay, and this is the gateway through which my packets will pass. Okay, and so when I want to ping to google.com or to get to google.com, I have to pass through this networks or simply this routers. So what RIP does is it will choose the best possible hop count. So now what is this hop count? Hop count is basically your neighboring routers, number of neighboring routers through which you will travel to your destination. So here I can travel through three ways. The first is through directly by 1, 2, 3, 4. The next is through 1, 2, 3, 4 and 5 through 5 router including my one, and the last one is through 1, 2, 3, 4, 5 and 6. So what RIP does is there are many ways to go through to google.com, right? So RIP will select the best possible way or simply your best possible hop count, which will consist of number of routers through which, and this hop count is only limited to 15. That means only up to 15 routers it can select the way, not greater than 15 routers or simply your neighboring routers. So here easily I can go through 1, 2, 3, 4. So I can pass through 4 hops, which is nothing but my 4 routers, and reach google.com rather than going through 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5, 6, right? So this is what RIP does. It selects the best and you can say the shortest or easiest way to reach your destination. Well, for selecting this path, now this router needs to know the address of all this particular routers, network address of all these routers. So that's what we'll see in practical now, because if the router knows the network address to which it is connected, then only it can select the best possible path, right? So that's what we have to do in our practicals. So let's start with our practicals. So before starting with the practical, let us first open our command prompt and we'll see on the command prompt how many hops do we require to get to google.com from my network. So I'll say we have a command called as tracer, and I'll say google.com. Okay, so tracing route to google.com, and this is the address of google.com. Okay, so you can see the number of hops is now 1, then it is 2. My service pro ISP is mtnl.net, so my service provider is mtnl, and you can see 3, 4, 5. This is the number of hops, okay, or simply your neighboring routers through which your data has been traveling. 7, 8, maximum is 15, not more than 15. 6, 7, and this is the associated IP to that particular router or simply the default gateway of that IP of that router. So you can see trace complete. So within 8 hops I have reached to my destination google.com. So these are the hops. So this is how tracer works. Now we'll see how RIP works in practically in our Cisco packet tracer. Okay, so we'll open our packet tracer and let's take a router 1841. Well, you can take any router, generic or 1841. If it is mentioned as 1841, then you have to take 1841, or simply you can take a generic router. Okay, and PC0, PC1. Now let's connect them with a wire, selecting automatic, choosing connection type, and here we connect the PC to router, and now from router to router. So always starting before configuring, make sure that you write this IP addresses so that it is easy for you to configure, and say 10.0.0.2 and DG, which is nothing but my default gateway, which is the router's address. Okay, so my default gateway would be 10.0.0.1. Similarly for this one, I'll just make a note of it so that it is easy for me to configure. For this I'll say 20.0.0.2, and my default gateway, which is nothing but my router's one address, would be 20.0.0.1. okay, Now for this particular network from router 0 to router 1, I'll give address as say 30.0.0.2, and for this one I'll say 30.0.0.3. okay, so before configuring, make sure let's configure PC0 first, then we'll configure router. In desktop, IP config, and we'll put the IP as it was 10.0.0.2. subnet mask, it automatically comes, and a default gateway was 10.0.0.1. Next for PC1, again desktop IP 20.0.0.2 and my gateway 20.0.0.1. okay, so I'm done with the PC. Now let's configure router. So always make sure hover your cursor over, hover your mouse over this particular line, and you can see here as FA0/0. okay, so our default gateway would be for this FA0/0. fine, whichever FA is been connected to this PC will be our default gateway. And just go to CLI, or simply you can come to config mode, and through this fast ethernet 0/0 you can go in either of the ways, by config or through CLI mode. So we'll do first with config. So our default gateway was 10.0.0.1. so now question arises where to put this default gateway, this address 10.0.1. so always remember your router is connected to this PC, right? So whichever hover your mouse on this line, and you can see FA0/0. okay, so for this, whatever it may be, FA0/1 or 0/0, whatever, maybe most of the time is FA0/0. so the router is connected to this PC, so this wire, whatever the notation is, FA0/0 or whatever it is, for that fast ethernet you have to put this default gateway. okay, so no confusion in that. And next one is for this FA0/1. so for this FA0/1 you will have this particular address, which is 30.0.0.2. so I'll click over here, and now let's go into CLI mode. So you can obviously configure through this also. So now let's try through CLI mode. We'll say exit, and we'll say int, which is nothing but interface FA0/1, and then I'll say IP add 30.0.0.2 and my subnet mask, which was 255.0.0.0, and I'll say enter and no shut. okay, and then exit. So you can check it over here for 0/1, your network has been configured. okay, no shut is basically to enable your port status to on. Now we need to configure this router. So this router, again look for this FA0/0. okay, so here our default gateway will come. We'll do FA0/0, which is 30.0.0. It was not 30, it was 20.0.0.1. our default gateway is enable the port on, and for 0/1 we were having 30.0.0.3 and make the port enable on. So our routers have been configured, routers and PC. okay, so now let's check by placing a packet from PC0 to router 1. it is successful. From this PC1 to router 1, successful. okay, now from PC0 to this router 1, it is failed. It is showing as failed because we have not configured this, right? So in static we were having something as next hop, okay, and then a network address of this particular area and your next hop. So I have a video on static routing. If you wish to, you can view it later, or simply to understand the static routing. So in RIP what we do is we go on a router 0, okay, each of the router. So this router 0 knows address of this particular network and this network. So what will be the network address for this tens network? It would be, let me make a note over here, as network address it would be 10.0.0.0. so this is my network address as it lies in class A. First value is 10, so class A has values range from 0 to 126. so 10 comes in class A, and for class A we have first bit as our net ID and rest of the bits as our host ID. So this is our network address. Network address for this particular, this is again in class A. So 30 dot, I'll say network address n/w network address would be 30.0.0.0. okay, and for this again we have network address as 20.0.0.0. so now this router knows this address, or simply this network address and this particular network address. So in RIP we have to simply go into config RIP, and in RIP routing network we have to add the network addresses which this router knows. So it knows about this network address which is of 10's network, 10.0.0.0, add, will say add, and second it knows of this particular network, okay, which is of 30's network. It is connected to this, so it knows this network address which is of 30's network. So we will say again add 30.0.0.0. so two networks are added, okay, and we'll say over here in settings, it will come in settings and we'll say NVRAM we'll say as save, because we want to save the running configuration whenever we trace the packet. So we'll simply say as save. NVRAM stands for non-volatile RAM. Next we have to configure for this router now, router 1, okay. So for router 1 again the same thing. This router 1 knows the address of this particular network which is of 20's network and this particular network which is of 30's network. It doesn't know the address of this 10's network. So we'll add, now this time we'll come into CLI and we'll try to add through CLI. We'll say we'll exit, we'll come into global configuration mode, and then we'll say as router RIP. So it will get into config routers mode, and then we'll simply say network and the address of the network which the router knows, which is first one, it is of 20's network, this particular network. So we'll say 20.0.0.0, and the second network it knows is of 30's network, okay. So we'll say network 30.0.0.0, and we'll simply exit, okay, and in settings we'll come and save. Done. So we have done configuration with the router 0 and router 1. Now let's trace the packet. We'll say PC0 to router 1 in progress, and it says fail. Well, it takes some time, don't panic. We'll again trace it. It takes time around say 10 seconds, and we'll check again progress, and again failed, okay. Why it is showing as failed? Have we put the default gateway? Yes, okay. Now let's check again PC0 to router 1, and it shows as successful. So it takes some time, okay, so don't panic, around 10 to 20 seconds it will take. Now let's check from PC1 to router 0, successful, okay. Now we'll check from PC0 to PC1, successful. So earlier it was showing fail, now it is showing successful. PC1 to PC0, successful. So that's how RIP works, okay. You have to just put the network addresses which the router knows, all the network addresses to which the router is connected or which it knows, and that's it, and then you have to ping it and you get the output as successful. So that's it from this video. Thank you so much, and stay tuned for further more videos, and don't forget to subscribe.